In this video, we will cover all the key points in JavaScript in 1 hour, starting from the very basics and moving on to more complex concepts. This video is not suitable for beginners because everything will be quite fast-paced, but it will be appropriate for those who already have a foundation either in JavaScript or in other programming languages to form their opinion about what JavaScript is all about. We will break down each individual topic into separate files. Let's start with the basics, variables and constants. For constants, there is the keyword const, and then we can specify the name of this constant and assign a value to it. Since this is a const, we cannot change its value afterwards. That would be an error, so I will comment it out here. When choosing names for constants or variables in JavaScript, there is a convention called camel case. If the name consists of 2 or more words, the first word is written in lowercase and the subsequent words are written with an uppercase letter. This is called camel case. To create variables, there is the keyword let, and let's say this will be our last name. But then, let's say 4 years have passed, someone got married, and we easily change the last name to Jones. So, such a notation is possible if this is indeed a variable. In JavaScript, we can create variables or constants starting with an underscore or, for example, with a $sign. That is, this is all completely valid, and we can also end with the same characters. This is not an error. At the same time, we can end a name with numeric values, but we cannot start with numbers. This will give us an error, so we can't do that either. That's why I'm commenting on this. Now let's talk about operators. Let's say I will create a variable current year, which will have the value 2024 when I record the video. And let's say I will have another constants, because the date of birth cannot be changed, let it be 1993. And we want to calculate the age. I create a variable age, and from the current year, I subtract the birth date. After that, we get the corresponding value in the required variable. Considering that we are working with numbers here, the operator dash will work exactly as it does in mathematics. At the same time, we can perform additional manipulations with numbers. For example, if we want to increment by 1, we can use the plus plus operator, just like in C++. In a similar way, we can write it as follows: plus equals 1, and then we simply add 1 to our variable. Alternatively, there is a similar longer expression where we redefine the variable h to its previous value plus 1. Each of these expressions is roughly identical. If we want to subtract the required number of values, we can write h minus equals 3, and thus we will return it to its original position, because here we added 3 units. Next, to see what we have in the variable, we can use the console log construct to output the desired variables. I will run everything on the node.js platform, that is, using the terminal, and for this, I will write node 1 base. As a result, we get the value 31 here. Next, there are comparison operators. For example, we can ask if the value of age is greater than 42. If we look in the console, we get the value false here. This is a Boolean type. We will talk about data types now. And, accordingly, we can perform strict inequality, and we can perform loose inequality by adding the equals sign. In this case, VS Code turns this into a nice symbol, but it actually says greater than or equal to. If we look at it this way, we get false. However, if we go back to 31, so we get true here because the variable age holds the value 31. 31 greater than or equal to the value of 31. If we use strict inequality here, then we will get false, respectively. Interestingly, there is a comparison operator present. For example, we want to compare age, and here I use 2 equal signs. That is, 1 equals is the assignment operator, while 2 equals is the comparison operator. And here we will compare it with line 31. If we look in the console, we ultimately get the value true. That is, when using loose comparison, the number 31 is equal to the string 31. Given that JavaScript is not strictly typed, such nuances are possible. Therefore, there is another operator, the triple equals, which compares both the value and the type. If we take a look, we will now get the value false because the number is not equal to the string. But if we convert this to a number, we will accordingly get the value true here. Now let's talk about data types. In JavaScript, there are currently 8 data types. Let's start with using the typeof operator, which shows what type our value is. We'll begin with the value true. I'll comment this out so it doesn't distract us. If we look at true, we get the first data type here. It is Boolean. In Boolean, there are 2 values, true or false, truth or falsehood. Accordingly, at each iteration we get a Boolean here. The next data type will be strings. They can be specified in quotes, using either double or single quotes in JavaScript. These will be our strings. We can also add some values here and still end up with the data type we need. The next data type is numbers. We have already discussed them. In fact, it is simply a number. Numbers can be both integer values and, for example, float values, meaning they can have a fractional part. The next data type that we will discuss in more detail a little later is the object. It is defined using curly braces. We can add some values here, keys and values, and we get the fourth data type, which is an object. There is the following data type. For example, it is possible when we create a variable, but do not assign it a value. If we look at x, we get undefined here. Undefined is a separate data type that has one value. Well, we can also explicitly define it as undefined. The next data type we need to be careful with is called null, but if we look at it, we get object in the console. This is one of the nuances of JavaScript. When we apply the typeof operator to null, it does not show its data type. So in this case, we can simply output null in the console. Null is a distinct data type that has only one value, null, which represents emptiness or nothingness. The next data type is relatively new. It is called symbol, and it is defined in this way. It is used to create unique values, for example, keys for different objects. The last data type we need to consider is called bigint, and it is defined in such a way that it is very similar to a number, but it has the letter n appended at the end. Either this way, or we can explicitly write bigint and pass some value like 10 here. The bigint data type is designed to allow us to work with very large integer values. Without losing the results of our calculations, it is also important to consider that there are some nuances. For example, there is a special value in JavaScript called nan, which stands for not a number. If we look at how the typeof operator works with it, we ultimately get a number here. It's quite funny because it translates to it's not a number, yet the data type of nano is indeed a number. We can obtain it, this value, for example, by dividing some number by undefined. That is, when combining these data types, the division operator is not defined, which is why we will not get a number here. So if we look in the console, we get, respectively, none. Next topic, let's break down how if statements work. And for this example, I will create a const called myStatus. Let's say it will have the value pending. Let's assume we have 3 values for this status. These are, for example, ready, pending, and failed. Pending, file. And depending on the current status, we need to output something to the console. Let's comment this out so it doesn't interfere with us. To do this, we write that if myStatus equals, for instance, ready, then in curly braces we will output to the console, let's say, let's go. In this case, we are ready to proceed. If the status is in another value, for example, pending, then here we write. Otherwise, if myStatus, you see, here I am using triple equals, which is a strict comparison operator, equals pending, which means the operation is not yet complete, then in the console we will output, for example, be prepared, which is a function to prepare for the next steps. Otherwise, we need to handle the third value, which is crucial for ensuring the program runs smoothly. Here we basically can no longer write an if statement because we understand that we have no more options. This statement will be specifically defined for the status value failed. So let's write failed. Now, if we run our script, we get be prepared because myStatus is in the value pending. If it has the value ready, then we will get accordingly, let's go. Failed, then we get the value failed. Next, let's talk about functions. Functions in JavaScript are defined using the keyword function. Let's say I want to create a function that will calculate the age of either a person or some element. Here we pass a parameter based on which we will implement our logic. And we want to return some value as the result of this function. For this, we write return here. Next, we need to determine the current year. We can do this using the newDate constructor. This is a constructor that works with dates in JavaScript and allows us to call its getFullYear method. And we can subtract the year, which we passed. Now, if we look in the console, for example, at the result of the function calcAge when using the number 1993, we find that people born in 1993 will be 31 years old this year. In this case, if we, for example, pass 2025 here, which is the next year, we will get a -1. So it's not quite the result we expected. So we can add logic to this function. For instance, I will create a local constant variable date and then check if date is less than or equal to 0. If so, we will return a string here. Let's say, you were not born yet. Otherwise, if this if statement did not execute and we did not make a return, then we will simply return date here. If we restart the script, we get the line, you are not born yet. If we pass some other value here, say 2020, then we simply get the desired value. This is how functions work. For now, let's comment all of this out so that we are not distracted by the consoles. And the next topic we will cover is arrays. Arrays are simply a collection of specific data in one structure. Let's say I will create an array called cars. It can be created using the newArray construct, but usually no one uses that because there is a much simpler way to do it with just square brackets. Here we list any values. These can be numbers separated by commas, or they can be objects separated by commas. However, in our case, we will be working with strings, so I will describe them in quotes. Let it be Porsche, let it be BMW. What can we do with arrays? We can determine how many elements it has using its length property. We can take a look at the first element in this array, referring to its index. We denote the index in square brackets as well. Indices start from 0. That is, if we want to look at the first element, we refer to the 0 index here. If we take a look, we get the value 3 here. This is the number of elements, and Tesla is the first element. If we want to look at the first index, which is the second element, we accordingly put a 1 here. If we want to find out what the last element is, but we do not know the length of the array, we can also refer to the length of the array and subtract 1, because the indices are always 1 less. And thus we will get the value BMW here. To iterate over arrays, we can simply use the basic for loop, where on each iteration we will create some index. Then we will specify what we want to do with it. But before that, we need to specify the condition under which we need to iterate through this array. That is, in order to perform the loop as long as I is less than cars. Thus, further in the curly braces, we can look at each element of this array in the console by accessing this array and passing a dynamic index. If we take a look, we get an iteration over the array. Also, inside the loop, we can create local constants, for example, car, where we will define by the index and then examine this car. For example, we can transform each string, say by converting it to uppercase, considering that we have a string using the toUppercase method. And now we get each element in uppercase. But in modern JavaScript, there is a simpler syntax for iterating over an array, for example, also using a for loop, where we create a variable car from the array cars on each iteration. And here we can also take a look at what we have in the variable car. And again, we get an iteration here. The syntax is simply more concise and modern. Arrays have various methods. For example, if we want to add an element to the end of this array, we can use the push method. Say we will add audio here. And let's look at this array. If we use the push method, we add audio to the end of the array, for example, and see what happens. If we want to add any element to the beginning of this array, we use the unshift method here. Let's start with a lambda function. If we look at it, we first get the Lamborghini and then we get the Audi at the end of this array. Similarly, there are other methods that, on the contrary, remove elements from the array, such as if we want to remove the last element of an array, then we use the pop method. And the pop method, by the way, returns us a separate constant which was contained in this array. If we look, you can see that Audi is not here, but if we look at last car, we actually get Audi, meaning we retrieved it from the array. Similarly, there is the method shift, which also retrieves the first element of this array, meaning here we write first car. If we look closely, you can see that the Lamborghini has been removed, but the value of the Lamborghini is still present in the constant first car. Arrays also have a quite large number of methods, and we will discuss them in more detail later, but for instance, we can use a method such as cars2car. Arrays have a variety of methods, and if we take a look, we get the same array but in reverse order. Interestingly, this method does not change the original array and returns a new one. Similarly, there is toSorted, for example, which sorts the array. Okay, let's move on. For now, I'll remove the console so it doesn't distract us. By the way, you can find the source code in the description of this video, and you can also play around with the basics of JavaScript. Now we will talk about objects, and objects in JavaScript are defined using curly braces in this way. Next, we describe here a key and a value where the key is simply the name of the field, and the value is its specific value. For example, I want to designate the name of this person. First name will be Vladilin. Last name will be Minin. Next, we can actually add any types of data here. For example, the year 1993. We can list in an array which languages this character knows. For example, English, Russian, German, and so on. We can add Boolean values like true or false. Is a person a programmer? Yes, and we can add various functions here. For example, the function grid. There are many ways to design the function. The simplest of them is to just put parentheses and then curly braces. Here we can definitely write hello from person. Next, we can absolutely, indeed, certainly look at this object. That is, if we simply pass person here and look at it, we get a listing of its fields and keys. We can access specific keys of this object, for example, in this way, and get its name. Alternatively, if we want to access the last name, there is an alternative syntax, also using square brackets, but here we describe in string format which key we need. In this case, we can use a dynamic key, meaning I will create a constant key that will equal, for example, year, and we can easily access a value by a dynamic key, such as yes, and now we should get 1993. This method is necessary, for example, for iterating over objects in a loop. As for the function, if the method is defined within the object, we can call it without any issues. For example, write person greet. This way, we will receive a greeting from the given object. Now, let's talk more about functions. To do this, I will create the following file, funcs.js, and there are actually two ways to create a function in JavaScript. The first is called function declaration, which is a type of. It looks like this. We have already discussed it when we create a function using the keyword function. And, for example, let's take some parameter here. Let's say name, and we will output the value hello from, and we will pass our parameter here. This is exactly a function declaration. There is basically another way to create a function, which is called a function expression. It differs in that we first create a kind of constant or variable, such as, for example, grid2, and then we store the value of the function here. Here there will be similar functionality. The only thing we will add is 2. And if we take a look, there will be the first call with the parameter max and the second call with the parameter, let's say, Helena. Now let's run this script, and we get hello from Max and hello from Elena. The difference between these two methods is that when we use a function declaration, we can call this function before its definition, unlike with a function expression. So, if I move the call up, in the first case everything will be fine, but in the second case we will get an error here. I run it, and we get an error here, although the first function worked. If we comment out grid 2 and run the script again, you see everything is fine. If we move grid 2 after we have defined our method, then there will be no errors either. This is related to how the interpreter works in JavaScript. There is an important point to consider when working with functions. If we apply the typeof operator to a function, I remind you that this operator determines the data type. We will ultimately get function. Although functions are actually objects in JavaScript from the perspective of data types, this is done here for convenience so that we can identify whether this name is a function or not. In JavaScript, we can also create functions using an alternative syntax, which is called an arrow function. For example, I will create a constant called error, and it will be defined as follows. Here I put parentheses, and then I put an equal sign and a greater than sign. You see, VS Code is transforming it for me. This is called an arrow function, and then in the curly braces, we describe the functionality. Let's simply duplicate it from our grid function. We can also easily accept some additional parameters here. If we call it with the parameter maxim, then we get hello from Max. Given that this arrow function contains only one line, there is no need to use curly braces, and we can eliminate them and simply write it in one line, which greatly simplifies the writing of any functionality. It is also worth noting that there are functions that do not just output some lines to console log, they can perform mathematical operations. For example, I want to create a function that raises a number to the second power. We take some number here, and then we need to use the return operator on this number, which we raise to the power of 2. By the way, this operator is exactly what does that. Now, if we look at pop2, for example, at the number 5, and we also need to output this to the console to see the result, then we get 25 here. But again, arrow functions are structured in such a way that if there is only one line, we can write it like this, and by default, it will be considered that we are doing a return here, meaning if we run it again, we get 25. At the same time, we can set default parameters. Let's say, if we didn't pass any number here, then we would have an error. We get none here because in this case it is undefined, and multiplying or squaring undefined would result in something unclear. But at the same time, we can do it this way and set a default value, say 2. That is, if we don't pass anything, then we get 4 here. Arrow functions are used, for example, when working with arrays. Let me show you a practical example. Let's say we have an array consisting of the numbers 1, 2, 3, 4, 5. This is an array, and we can apply various operators to it, for example, the map operator. We want each value in this array to also be squared. And in the case that we use the map method, we need to accept goback here, which is a function that tells us what needs to be done. We can define it using the keyword function, write return, and so on. But this is quite cumbersome, so it's better to use arrow functions here. This will be, let's say, n, and we will also duplicate the functionality. If we take a look, now each element of the array has been squared. However, considering that we already have such a function, we can pass it directly as a reference, thus reducing the time spent on code. And we can also see how readable and beautiful it looks. Thus, it is possible to write quite powerful functional code in this programming language. Similar to the map method, there is a very useful method called filter. The filter method filters an array and returns a new one. That is, for example, on each iteration we will get an element from the array and compare it, returning only those elements that are exactly divisible by 2. And in the end, as a result of this statement, we get a new array that contains the odd numbers, meaning that this operator has filtered out the even ones. It is also important to highlight another very important method that is available for working with arrays. Let me write a test function that will sum all the incoming parameters. But the nuance of such a function is that we do not know what parameters we will pass to it. For example, we want to call the method sumAll with the values 1, 2, 3. And we also want to call it with the values 1, 2, 3, 4, 5. How can we write a universal function that will do this? For this, there is a special operator in JavaScript called rest. It is represented by 3 dots. And then we specify which array we need to store all the incoming parameters in. That is, all is an array. Now we can execute this logic. For example, create a variable res, then use a for of loop to iterate over the entire array, that is, let n of all, and then add n to res. After that, we will return this value. If we look at it, in the first call we will have a value of 6, and then we get 15. However, there is a more convenient method that solves the same tasks. We can access our array all and call a method called reduce. The reduce method reduces the array to a single value. And the first parameter it takes is a callback, which we will describe as an arrow function. This callback has the first parameter, the accumulator, which changes with each iteration, and the specific element in the current iteration. So, we will proceed as follows. Let's return and modify the accumulator, adding the value of n, which is the element of this array, at each iteration. The second parameter in the reduce method is the initial value, and in our case, it will be 0. Now let's see, we are getting undefined here. Why? Because we got a number here, but we didn't return it. That is, we also need to add a return here. We get the same values, and if we specify that the starting number is 10, then we get the result increased by 10. When working with JavaScript, it is also important to discuss the concept of closures. Let me show you a simple example of what this means. Suppose I have a method called createMember, and this method will take a parameter first name, which is the first name of the person. The concept of closure here is that within a function, we can organize an inner function that will have access to the values from the outer, or parent, function. And thus it will encapsulate this value. Now I will show an example, and it will be clearer. That is, here we can return a new function that will in turn take the parameter last name. And, for example, in the console, we will simply output the result as first name plus a space plus last name. The result of this statement is a string, so I am adding a space here to make it more readable. Now, what the concept is about. We can create a new function that I will call logWithLastName. I call createMember, and here we are closing over one name. For example, John. Why is this a function? Because the result of the createMember function is a function. That is, logWithLastName is now equal to this function. And, accordingly, we can pass the last name parameter here. Let's take a look at it. Suppose I pass do here. And we get the corresponding result here. Also, now I can call the same function with a parameter. And in the end, we get the same name, meaning John's name was closed. But now, by calling this function with different parameters, we get the corresponding result. Now let's talk in more detail about objects. Let me copy the object for this to shorten the explanation a bit. We already have the first, character. What else should we consider when defining objects? The presence of various complex keys, meaning that, for example, we can denote them with quotes and specify the value with a space, will also be considered a key of this object. We can also perform various calculations on the keys of this object. This is described using square brackets. Well, for example, if I write the line key underscore +1 +2, for instance. If we look in the console again at what we have as person, so here we get a complex computed key 3. It's obviously obvious why. There is also a key with a space. In addition to being able to create methods within an object in this way, we can also create arrow functions. They are described using a colon. And then we write the body of the function, for example, console log error. Now let's see how this will work. We get the corresponding result. And also, let's say I will create a function here called info. By the way, it can be created using the keyword function. This is an absolutely identical record, as shown here. But this is just an older way. And here, let's output an interesting construct like this. My name is. And here we will indeed specifically refer to the keyword this.name. It is intuitively clear that this refers to the object in the context we are currently working with. So theoretically, this should be a person. And only considering that we don't have a name, let's refer to first name. Now let's call this method info, and let's see what it gives us. It outputs the corresponding string my name is. In this case, the keyword this, defined in the functions within this object, refers to the keys of this object. Yes, and we can access others, for example, year, and get the corresponding values. That is, there is no need to specify person each time. Important exceptions are arrow functions, which do not create such a context. In arrow functions, we cannot refer to the keyword this because, in this case, if we call the error method, it will not point to the object. It will point to what is above it. Within Node.js, a blank object is shown in the console. If you run this in the browser, it will show you the global object window. However, if we look at this, which is specified in a regular function, it should show us the object itself. Now, what operators are present when working with objects? For example, we don't like the arrow because it is not intuitive yet, so we just want to remove it. We remove person arrow. We can access any of the fields. And now, if we look at it, we will see our original object, but it will no longer have the key arrow. There is a concept called destructuring. For example, yes, we want to get specific keys from our object. That is, we can write curly braces here, right? We are creating some constants from the person object, and then we specify them in order. For example, first name, last name, year. Now, if we look at each of these constants in the console, they will have the value that is associated with the object. But this is done for convenience, so that you don't have to write, for example, like this every time. Const, let's say, length equals person, length. You see, the symbol is repeated here, which is why they moved away from such syntax. In this case, there is a default value, meaning that, for example, if we want to retrieve the constant not found, and we know that it is not in our object, we can add some default value, such as 404. Yes. And now, if we look at it in the console, at this constant, let's make it not found here. If we do not define this key in the object, we will get 404. However, if we define this key in the object itself, then we will get its value of 42. If we want to iterate over all the keys of this object, we can use the following construct, object keys. This construct will return the keys of the entire object as an array in JavaScript or in other languages. We can check this by applying console log, and we get here, you see, an array consisting of strings that are the keys of this object. And then we can, for example, use a loop like for each to apply it to the array, because this is our array. On each iteration, we will get the key, this dynamic one, and for example, output person and then key in console, log, as we discussed earlier. Here, let's get rid of the end of the log, because there is already an internal one. If we take a look, we can see that we are getting all our necessary values here. At the same time, it is also worth diving into the basics that exist when working with objects. For example, in the object person, we have a method info that currently outputs this. Let's have it output first name, and, for example, we have another object. Let's create it as a new entry, named person2. It will have the key first name with the value maxim. The task is to call the method info, but not with person, rather, with the values of this object. How can this be done? We can refer to person, access its method info, and then call a method on the function java.crypt, which is possible, for example, with bind, which changes the context of the call. And, for example, here we will pass person2. This means that we are now binding the function info to the object person2. So, this will now refer to person2, and accordingly, we should now get my name is Maxim. Given that bind returns a function, we can assign it to a constant called bound and then call it. And to see what we get, we see that we indeed get my name from Maxim. However, if we bind to the person itself, then we get owner here because in its context first name is at this value. Similarly, there are methods like person, info, and the call method which does the same thing as bind, but it immediately invokes the function without returning anything except for the result of the function's execution. And we can also pass person2 here, for example. We look and get Maxim here. There is also the apply method, which does exactly the same thing as call, but in the case of the call method, we pass additional parameters that this function can potentially accept, separated by commas, for example, 1, 2, and so on. In the case of the apply method, we only take 2 parameters, while all other parameters are specified in an array. This is the only difference, but it's important to know. This is something that is often asked in interviews. I have a detailed video on the channel about how to go through an interview with all the theory on JavaScript. I also need to say a few words about such a thing as prototype. And for this, let me create a file index.html. Using Emmet, I will create the basic structure and write the script here. We need this to make it a bit easier to look at the structure of objects. And let's assume I will have a base object here that has a method. Let's say great. And it will do something complimentary, like telling you that you are great. Now let's run this in the browser. I will run it in the default browser and check the console to see what it shows us. If we turn to our object obj, we see that there is a method seggrade present here. That is, if I call this method, we basically get the value you are indeed essentially great. But here's what's interesting. We defined only one method in this object, and if I call a method like toString here, you see, it all works. That means we have such a method as well. You might ask, why does this work at all? And here, everything lies in the concept of prototypes, on which all objects in JavaScript are built. If we output a value like obj in the console, 2_proto, and look at them in the browser, we get a separate object that contains a reference to the prototype of any object in JavaScript. Here we can see the toString method that we called earlier. To put it simply, if we look at the object in the console, when we expand it, we see that there is a method that we defined at the same level as the fields and so on. But there is also a prototype that refers to the base object, and if we expand it, we can see that the other properties are already present. In other words, if it does not find the methods we are calling at this level, it goes to the prototype, and such a prototype chain can be made quite long. Again, there is a detailed video on this topic on the channel. Check it out, and it will be clear to you. Let's move on. And the next concept we will discuss is asynchronicity. Let's look at 04.async.js. In JavaScript, we had the ability to write asynchronous code, and here's what it looks like. The basics start with a method called setTimeout. The setTimeout method takes a function as an argument. We can describe it in this way, or in a more concise version using an arrow function. The second parameter is a number that specifies how long to wait before calling the function. This parameter is defined in milliseconds. That is, if we want to make it 2 seconds, I pass 2000 here, and for example, in the console log, I will specify the value after 2 seconds. Now, if we run this script, at first nothing happens, but after 2 seconds, we get the coveted console log. Similarly, there is another method called setInterval. I will write interval here and let's run the script again. After 2 seconds, we get a timeout, but the interval will execute periodically every 2 seconds. In other words, this way we can perform repetitive actions, such as changing the date and time on the clock. By the way, to exit the console, you can press Ctrl+C. To clear a timeout or interval, we can store the result of its execution in a separate constant, such as timeout, and clear it using the clearTimeout method. The same will work for an interval. That is, when we cleared the timeout, we will now get nothing in the console at all because we created it. And then it was immediately cleared, which is why this method is not executed. If we do this with an interval, let's clean it up only after some timeout to ensure everything is in order and functioning correctly. I will move the logic here. Let's say I will clean it up after 7 seconds, after a certain period of time. Here I will call the clearInterval method and pass the interval constant, which is responsible for this functionality. Now we should see several console logs, but after 3 calls, the program will terminate because we cleared this interval. As a small practice, we can create a method called, for example, delay, and wrap the timeout functionality within it. Here, we will accept some function. By the way, functions can be passed as references in JavaScript, and for example, we can set a parameter to default to the value 1000, which indicates how long to wait. If we do not pass a parameter, then by default it will be 1 second. Then we call this setTimeout with a function and with the parameter wait. In other words, overall we did the same thing. Not very useful work, but now our call can be more concise after 1 second. If we run it, we get the result after a second. But at the same time, we can customize it, say, to do this after 2 seconds. Let's check. Yes, it works. But as I already said, the fact that we created such a function is not very useful because we are still in a callback. It's not very convenient to manage this. Even in JavaScript, there is a concept known as callback hell. This occurs when there is a huge number of nested functions present. In general, this is not very scalable and flexible, which is why there is another concept for working with asynchronicity in JavaScript called promises. Let's see how we can create the same delay using promises. but in a more convenient way to work with it. I am creating a delay. Next, I will have this as an arrow function. And here I will specify the parameter at the input. Also wait. Let it default to 1000 milliseconds. Next, inside, we will also have asynchronous code built on setTimeout. Yes, we already know how to work with it. So here we have the first callback, and here we pass as the second parameter how long we need to wait to execute the functionality. So here I am passing the value wait. It seems like, what have we done new? And the fact that we can wrap all of this in a promise. How does it work? We basically establish the new promise structure, and then essentially this is our class. In fact, in its constructor, we accept a callback here. This callback always takes two parameters. There are two more functions, resolve and reject. The essence of a promise is that it wraps any asynchronous code to make it easier to work with. Look, here's the idea. It's that now inside this timeout, we can signal ourselves when our promise will be resolved. Well, for example, after this second, by default, I will call the resolve method, which will signal to us that the asynchronous code has finished, and we can proceed to do something of our own. Accordingly, for our function to work properly, we can either write return here right away, or to make it clearer, we can write const promise here, which means creating a constant and then returning it. Overall, it will be the same thing. Now let's look at what all of this has given us. Remember how we called delay last time? Well, it's the same now. Let's say I want to create a delay of 2.5 seconds. And then we have the option to call several methods through this chain operator that is essentially basically using a dot. For example, then, here we pass a callback, meaning we specify what we want to do once this function is completed. Well, for instance, log to the console after 2.5 seconds, or approximately 2,500 milliseconds. Now, if we just look at our code, we wait 2.5 seconds and we get the same result. But now we indeed have the ability to handle errors and clearly control the entire process. For example, in den we can create a constant there, let's say number equals 40, and return that number. We can continue this chain of zens and transform the data in some way. That is, right now we are getting some for variety. I will write my number so you understand that you can name these variable parameters however you like. And here I can write after in the console or terminal in the output section and output this value, yes, meaning that a chain of transformations can occur, which is quite convenient because it is decomposed into different logical blocks. You see, they are interconnected. In this case, if, for example, our asynchronous code throws an error, we can signal this by calling not the resolve method, but the reject method, which we also accept in the promise constructor. So here we can write my error in this specific section of the code, which is important. Promise. To basically handle this error, let's first execute the promise. You see, we encountered an error that completely breaks our program. But if we add the method cage, yes, and it is definitely present in any case, meaning we don't need to change the logic of our program at all, then we encounter some error here. Let's output it and see what it says. Let's run it. You see, instead of breaking the program, we simply get an error, and then we can adapt the behavior of our program in some way. There is also a method called finally in a promise, which is called in any case when the promise is completed. Let's say in any case anyway. Despite the fact that we had an error, we still received this console.log. Again, regarding more detailed work with promises, you can find videos on my channel to learn more about it. But right now, I want to give you a slightly more practical example of working with them. For example, I will have a method called getData. It will also be an arrow function that will return a promise. Say return because we are currently in an arrow function. And considering that this will all be in one line, we don't need to write return. Here I write promise. Here I only accept one resolve, yes, because we won't have any errors here. So let's specify some numbers here. For example, Fibonacci 1, 1, 2, 3, 5, 8, and 13. That is, the method getData will return this set of data through a promise, but we forgot to put them in the resolve method like this. So moving on, we can simply see how to work with this method. That is, we get getData, then here we get some data. Let's take a look at it in the console. We get the corresponding numbers, but we know that they are now locked in a promise. In theory, this could be asynchronous code that comes to us from the API. Let's just make it a little easier for us to navigate in the console. I will remove this delay and comment it out. And now look, instead of working with these then catch, finally, and so on every time, we can take advantage of the modern syntax. In JavaScript called async await, which allows us to write code that looks like synchronous code. I will name the method async example. Point here is that in order to work with this operator, we need to make the function asynchronous. That is, we basically add the async modifier here. For example, I can actually wait for our delay function to complete, let it run for 3 seconds. And let's remove the error here again and make it resolve so we have no errors. After that, I will call this async example, skipping. You see, everything worked out. Yes, we haven't received any console logs yet, but in any case, with the help of such an operator, we waited for this delay to complete. Now, if we want to work with the data, for example, with the method getData, then let's also consider that this is a promise, so we can write await. GetData, and we want to get the data here, that is, earlier we received it like this through the method, then essentially, basically, in essence, data, and so on, etc. Considering that we are using await here, we simply create a constant data and wait for this method to complete. Next, we want to take a look at it in the console to see if everything is okay with this data. Let's run the script. We wait for 3 seconds and again receive our original array. So you see, in this case, we no longer specify these then, and everything is quite linear. But what should we do, you might ask, if we need to handle an error, for example? Then we can wrap all of this in a try-catch block. It is described this way. Then we simply put all our logic into the try block. If everything goes well, we will remain within this logic. If an error occurs, we will enter the catch block, where we can simply log this error to the console. Now let's run it. You see, everything is absolutely perfectly fine, yes, because there were absolutely no errors. But if we make a mistake in our timeout again and execute the script, then you see we get an error here in the promise, which means we hit the catch block. Similarly, the keyword finally is also present here, which will execute in any case, regardless of whether it was done successfully or if there was an error. As you can see, we still get an error here, but we actually ended up in this block anyway. Well, I suggest we wrap up this quick course on JavaScript. It was quite challenging to cover everything in just 1 hour because the language is very extensive, and there are many different elements. But in reality, this is the entire key foundation that exists in the language, and from here you can start trying to write your own logic and so on. I would also like to draw your attention to the fact that my channel has a large number of ready-made courses, both for beginners and for advanced learners, which explore each of these topics in more detail, and you can learn simply by watching the videos on this channel. So I wish you success, subscribe to the channel, like the videos, hit the notification bell, and see you in other videos.